Hi. In the guided worksheet for Week 2, Section 1.4, you'll be studying complex numbers, and you should be able to perform the following operations: addition and subtraction, multiplication, finding conjugates, which will help us learn how to do division with complex numbers, and then finding square roots of negative numbers. The material in this section is really motivated by what we need to do in the following section. We'll be studying equations whose solutions may involve the square roots of negative numbers. So we're going to need to know quite a bit about complex numbers first. Well, complex numbers can be defined as having this form. They look like a plus bi, where a is called the real part and bi is called the imaginary part. A and b are real numbers themselves. Okay. Well, the imaginary part, has some significance to it because we can actually define what I is. So I just isn't a variable. It represents the square root of negative 1. So it's defined to be the square root of negative 1. And I squared is defined to be equal to negative 1 itself. All right, let's take a look at first two kind of simple operations involving addition and subtraction. You can think of this as what you've done with polynomials when you're adding two binomials, where perhaps you had an x involved. So think of this as maybe 5 minus 2x plus 3x, right? What did you do in that case? You'd add together the numerical parts, right? And then you'd add together the parts with the like terms. We're going to do a similar thing here. We just want to remember later that I is not just a variable, it represents the square root of negative 1. All right, so let's just follow that. We can actually drop the parentheses, right, and thus rewrite the first line. And then in the second line, I'm just showing you how we can put together the real parts, which is the 5 plus 3, and then we can group together the imaginary parts, which is negative 2i plus 3i. So we get 8. If I add negative 2 plus 3, that's a positive 1 times I. So we'd have a 1i. So our answer is 8 plus i. When we subtract, the only thing we have to be aware of, since we're subtracting this entire complex number on the right, we have to distribute that negative sign. So it becomes 2 plus 6i minus 12 plus i. Let's regroup. We'll put the real parts together and then the imaginary parts together and simplify, and we get negative 10 plus 7i. All right, so that wasn't too bad. Now what we'll need to do is work on our multiplication. The main thing you have to remember for this is that I squared is equal to negative 1. We're going to need this fact and use it over and over again in each of these problems. So let's start with more of a basic product that we have to find. It's just a single term, 7i, times this complex number 2 minus 9i. Well, you're familiar with how to handle this. You just have to distribute that 7i. So it turns out to be 14i, and then 7i times minus 9i is negative 63i squared. Do not forget the I squared part. The square is very important. Okay. The next step would be then is, well, we have to now use our definition. So we can't just leave it in terms of I squared because I squared is defined to be negative 1. So we have to replace it with negative 1. And then we can still simplify. So nothing happens with the 14i. We leave I as it is. We don't replace the I with the square root of negative 1. We just leave it as I, but we do have to replace the I squared. So it becomes 14i, and then negative 63 times negative 1 is a positive 63. Notice I'm going to write it in the form a plus bi, so I have to put the 63 first plus the 14i. Okay, in the next example, just want to show you if we have a complex number with two terms times another complex number with two terms, we have to use the FOIL method. So first term, 5 times 6, we get 30. The outer term, 5 times negative 7i, is negative 35i. The inside term is 4i times 6, which is 24i. And the last term, be careful here, it's 4i times negative 7i. So we have to multiply the 4 times the negative 7 to get negative 28. And don't forget to multiply I times I, which gives you I squared. Now we're just going to work through and simplify it. Then in this next step, I automatically, whenever I see an I squared, I know I have to replace it by negative 1. I can combine the 35i and the 24i to negative 11i. So this is what the second line looks like. Notice that in the third line, we carry down the 30 and the negative 11i, and then I can multiply negative 28 times negative 1 to get a positive 28. I really think these steps are crucial. Of course, you could do them in your head, but the more you write down, the less errors you'll make. The last step then, just group the real parts together, so we get 58, and then include the imaginary part, which is negative 11i. In part C and D, I just want to point out that if I have a complex number and I'm raising it to a power, in this case the power is 2, I take that complex number, since it's squared, and I'm going to multiply it by itself. I don't change any signs. I'm not factoring. I'm not doing anything like that. I'm just, multiplying 2 plus 3i times itself. So I need 2 factors. And then we'd apply FOIL. So it's going to be 4 plus 6i plus 6i, and then plus 9i squared. So we get this second line. The I squared, remember, immediately you want to change that to a negative 1. So it becomes 4 plus 12i minus 9. And then I can combine the real parts to make it negative 5 plus 12i. Try this part with 5 minus 2i squared. And just check your work against mine to make sure you get the same answer. Okay, now we're moving on to division, but we need to know one thing before we move on to division. We need to know what is called a complex conjugate of a complex number. So if we have a complex number, a plus bi, and we want to take what's called the complex conjugate of that number, we just change the sign in front of the imaginary part. So the complex conjugate here would be a minus bi. In problem 3, let's take the product of the complex number a plus bi and multiply by its conjugate to see what we get. I'm just going to FOIL it out. Watch what I do. So a times a is a squared. Then I have a times negative bi, so it would be negative abi. Then I have bi times a. I can write that as a bi, positive. And the last term is going to be negative b, it should be positive b times negative b, right? Which will be negative b squared, and then times I squared. So just think of this, the plus times the minus makes it a negative, and then I have to say b times b is b squared, and I times I is I squared. Well, the neat part about this, since it's a plus and a minus, they cancel, right? The two terms with the i's in it cancel. So I'm just left with a squared and then minus b squared times I squared, but I'm going to replace I squared with negative 1. So the negative in front of here times this negative makes that a positive. So look at what we have. We have an answer that does not involve I. It's a real number. It's not a complex number. There's no imaginary part. So that's the consequence of this, and that's what's going to be useful when we're dividing complex numbers. Right. So the goal of complex number division is to come up with a real number in the denominator. All right. We're going to multiply the numerator and the denominator of a complex number by the conjugate of the denominator. That's what's important to obtain a real number. So let's see how we do this. Suppose we'd like to divide 5 plus 4i by 4 minus I. Okay, I'm just going to write down the problem, right? And then I'm going to multiply by the complex conjugate on the top and the bottom. Remember, this is just multiplying this fraction here, the original fraction, by 1. So it's really not changing the problem. But what is the complex conjugate? I have to change the sign in front of the imaginary term. Since it was a negative here, I have to change it to a positive. Then I'm just going to multiply the numerators and multiply the denominators. Okay, so you just have to be pretty good at multiplication and the FOIL method in this case. So multiplying the numerator, it turns out to be 20 plus 5i plus 16i plus 4i squared. The denominator is 16 plus 4i minus I squared. Notice that the 4i's cancel just like they did above here. Okay, good. Let's just see what we can, any kind of work that we can do. Well, the best I can do right here is 5i plus 16i is 21i. All right. And I also have canceled out the 4i and the negative 4i. If I scroll down, if we could just move down here, okay, I've just copied over the numerator, except I've replaced I squared with negative 1, and I've done the same in the denominator. So then when we simplify it, this is really 20 minus 4, which is 16. Just carry down the 21i, and then this is 16 plus 1, so I get 17. So when you do this, you'll always get a real number in the denominator when performing complex number division. Now, what you might see is this written in a slightly different way. So I would write 16 over 17 plus 21 over 17i. So this would be the way you'd see it if we wanted to find out what the a is and the b was, to write it in the a plus bi form, the standard form. Okay, let's try another division problem. Here I just have a single term in the numerator, right? And I want to multiply this fraction by the complex conjugate in the numerator and the denominator. But I'm always taking the complex conjugate of the denominator. So I just have to change the sign here from a plus 2i to a negative 2i. Multiply the same thing on the top. All right, and then multiply negative 6i times the complex number 3 minus 2i, and then multiply these two together. Okay, if we go down just a little bit, here I get negative 6i times 3 is negative 18i, and negative 6i times negative 2i is positive 12i squared. I'm going to let you FOIL out the denominator and make sure you obtain this answer here. Your middle terms with the I should cancel. Notice I have an I squared in the numerator and the denominator. So what I did was just replace each one of those by negative 1. And then I'm just simplifying where I can. So this numerator becomes negative 12 plus 18i. I'm sorry, minus 18i. And then notice it's 9 minus 4 times negative 1. So it's really 9 plus 4. You get 13. We can divide this 13 out into each part, right, because it's a common denominator. And then this is the complex number that we'd obtain. Okay, so that really covers addition, subtraction, multiplication, and division. There's one other thing that we'd like to take a look at, and that's this certain property in which we can simplify square roots involving negative numbers. I'm going to stop here now with this video and continue on in the second video. So there'll be part 2 to this guided worksheet.